Well, speaking of the next computing platform, the big announcement was a new quantum computing chip. And so
that they had sitting on the desk, right?
Yeah.
Which
So
is cool.
Quantum computers you might have seen have been, it's usually like this superconductor, like frosty, like super cold, like gold, like crazy looking device in essentially a lab. Certainly not something you can rack on a server. Microsoft claims to have boiled it down to a point where this could potentially be scaled into millions of qubits, which are quantum, which we'll go through here. So Elon shared a Grok analysis of quantum computing and the Majorana 1 chip, which is Microsoft's new quantum computing, quantum processing unit. So we'll give a quick overview of quantum computing. Imagine a computer so powerful it could solve problems that today's supercomputers can't even touch. That's the idea behind quantum computing. Unlike regular computers, which use bits that are either 0 or 1, quantum computers use qubits. Qubits are special because they can be 0, 1, or both at the same time, thanks to a quantum property called superposition. This allows quantum computers to process huge amounts of information all at once, making them potentially game-changing for tasks like simulating complex molecules for drug discovery, optimizing massive systems like traffic or supply chains, and cracking tough math problems. There's a catch. Qubits are incredibly fragile. They can lose their quantum state and thus their information due to tiny disturbances like heat or noise. This fragility is one of the biggest hurdles in making quantum computers practical. Now, Microsoft launched the Majorana chip, Majorana 1 chip, and it was funny because in the interview, Satya's like clearly heard about the project for a long time, but he like didn't know the final code name because they probably have code names and then they're launching it. He's like, I think we're calling it Majorana. He kind of had to like check that, but.
That's founder mode.
It's a new QPU, quantum processing unit, which could be the successor to the GPU, the TPU, now the QPU. Yeah. It's designed to tackle this fragility problem. It's the first chip to use a topological core, a cutting-edge approach that leverages exotic particles called Majorana particles. These particles help create a special kind of qubit called a topological qubit, which is more stable than the qubits in most other quantum computers. Here's what stands out. Material, it uses a new type of material called a topoconductor. It's more stable and it's more scalable. And so Microsoft designed this explicitly to support 1 million qubits, which is a huge leap. And at that point, you can actually start doing like real math and real problem solving, as opposed to a lot of the systems that
being
IBM and Google has worked. Science project. It's like, oh yeah, it's 10 qubits. It can theoretically do the hard math, but it can't practically actually solve
so
many problems.
So many companies that had what was that AI project? I forget who he was in. It wasn't started with a W, maybe. Like they're always saying, "Oh, it soled this."
There's D-Wave, and there was Rigetti.
No, I'm not talking about chip. It was like IBM. What was IBM's big AI project?
Watson. Yeah, Watson.
Watson got smoked.
Watson did get smoked. It's
Watson
very
fell
sad.
off.
Yeah.
And
they crushed in Jeopardy for a while. Yeah, that was a good stunt.
It's interesting that it seems like these big, legacy computing companies had these science projects, and they seem to be content with them being science projects and being this sort of marketing, right?
Yes and no.
Because Watson, I haven't even seen anything about it in the last year.
Well, now Watson is a consulting group that will help you implement Llama, essentially. Mogged, but also, as we've seen, there's a lot of money to be made in just AI transformation.
Sure, but why have a decade-plus long science experiment that you just end up as a consultant implementing?
Because it's a
Llama?
marketing project for your consultancy.
Okay.
And so
I'm just saying,
and so like when you call ExxonMobil and you say, hey, we want to help you implement AI, and you say, what company are you from? We're like IBM. We're the Watson Group. You remember the Jeopardy thing? Yeah. We've actually partnered with Facebook and Meta to vend in one of the greatest LLMs at the lowest cost.
Yep.
Not a bad pitch, not crazy, but the real reason why they missed out is that they weren't deep learning pilled, they weren't scale pilled, and Ilya Sutskever, like the magic at OpenAI was that there were a ton of papers that were being released around the same time. He read the Transformer paper and was like, this is it. And he identified that and was like, let's go implement this and let's scale this. And that was just a very, very key thing. It is interesting that everyone else is catching up and Watson isn't like, hey, us too. Because they could have done, if they were cracked, they could have done like a DeepSeek thing or a Llama fine tune or a Mistral.
I also wouldn't be surprised if the best people at Watson got poached to go to the other
Yeah, but I mean, the company is not set up as a research like software enterprise company anymore. It's very much a lot of consulting. Anyway, let's go back to the Majorana chip. It relies on Majorana particles, which are fascinating because they are their own antiparticles. This property makes them ideal for storing quantum information in a way that's naturally protected from certain errors. Picture it like this. Think of a regular qubit as a spinning coin that's easily knocked over by a breeze. A topological qubit is more like a knot tied in a rope. No matter how much you shake it, the knot stays secure. Interesting metaphor from Grok. Microsoft achieves this by using a topoconductor, a material that combines the properties of a conductor and a topological insulator. This setup allows them to create and manipulate Majorana particles, forming stable qubits. Why is this a bigger deal? Well, more stability, faster progress, and Microsoft is super committed to this. They've been researching this for 20 years, and they've had a bunch of stuff.
See, that's the kind of stuff, like, I want to see the 20 years of research, and then boom. We're going to commercialize this.
Yeah, and so they actually had some setbacks. In 2018, they published a paper on quantum computing, and they had to retract it because there was so much pushback from the scientific community. And so the article highlights potential applications. They're going to work on self-healing materials, sustainable agriculture, safer chemical discovery, and going forward, they still have to scale up. Going from 8 qubits to 1 million is a massive engineering challenge. It's not just about adding more qubits. They all need to work flawlessly.
We're focused on doubling here.
Yep.
They're focused on
like
going 8 to 1 million.
But all the best, projects are. But let's go to Nature. So I believe Microsoft published their paper in Nature, and there was some pushback. Cool. And I have an article here from Nature that will kind of show, a little bit of truth zone on Microsoft claims. We'll see if we agree with it or not. We'll let you be the judge. So he says, Microsoft claims quantum computing breakthrough, but some physicists are skeptical. The tech giant aims to make topological quantum computers that will reach useful scales faster than competing technologies. And so machines based on topology promise to be easier to build at scale than competing technologies. So again, it's not that they've built the 1 million qubit machine yet. They're just saying, hey, the tech tree has been going this direction, and we think if we go in this direction, it'll be a faster shortcut to the quantum computer that we want that will actually be able to simulate the universe essentially. Like the qubit, the whole thing with quantum computing is that you can do such complex, you can break encryption, but you can do such hard computing problems that you can actually instead of just physically modeling the pen dropping and it's the pen has a weight and there's a force. It's you can model each atom in the pen and it's no problem. Sure, that even though that would be
sounds good, boss.
Insane amount of calculations. So the announcement came in a February 19th press release containing few technical details, but Microsoft said it has disclosed some of its data to selected specialists in a meeting at its research center in Santa Barbara, California. Would I bet my life that they're seeing what they think they're seeing? No, but it looks pretty good, says Stephen Simon, a theoretical physicist at the University of Oxford, UK, who was briefed on the results.
It's got to be such a crazy dynamic doing this frontier research in a space like quantum computing, and any day you don't know if you're going to wake up and your nemesis is going to publish this sort of groundbreaking piece, and then you have to sort of react to it, but you got to be somewhat supportive because you ideally want the space to be pushing forward and getting more investment. But then simultaneously you want to be the guy that has the breakthrough that really matters. So he's it seems legit. Wouldn't bet my life on it.
And so I say at the same time, the company published intermediate results, but not the proof of the existence of topological qubits. And so big question on what was on that chip, because it's kind of the classic, there and I got the thing and who knows if it's working and it's not working. And it's why did you instantiate in the physical world? Clearly from a marketing perspective, the reason that you say I'm showing you the iPhone is because it's real and you can buy it. And Steve Jobs pulled it out of his pocket and was this is a real thing. You won't believe it.
Beth brings a chip around.
Yeah, Beth Bezos does this too. I think Beth Bezos is in one of these tweet threads being why is this a big deal? I don't care about this. It's heating up. But I mean, in the markets generally, quantum computing has become very hot. There's a lot of SPACs that were down and now they're popping again. And so I'm sure we're going to be hearing more about this. The very interesting thing is that most of the techno optimists.
Yeah,
really
I'm going to pull up people. On public. What was the...
look up Rigetti Computing.
Rigetti.
I think that's probably a good one. D-Wave, I think, as well. But It's very interesting because you can look at all of this. It's like one of those things where people overestimate what can be done in a decade and underestimate what can be done in a century, or overestimate what can be done in a year, underestimate what can be done in a decade.
Yeah, Rigetti's all over the place. They're up 16% this month, but it's been up 700% the past quarter.
Yeah, so. I told you. Yeah, 10x. So what's the market cap now?
They're 2.68 billion.
Wow.
Losing 60 million a year on 11 million of revenue.
Yeah, I mean, they can't possibly have revenue because they haven't created a quantum computer. No one has. Like, it's not like there's no work to be done. It's a research organization now, but you're betting that they will be one to commercialize, and if they do, it'll be extremely valuable. So good luck to them.
Wait,
what you got?
Somehow up that. Yeah, I misread. It's 960% over the past quarter.
So it's 10x over the last quarter.
Yeah.
Wow. Yeah. So
Not
it's
bad.
a $270 million company, and now it's a $2 billion company.
Hopefully other, companies, Satya sees this and says, okay, this is a new bar now. I need a 10x Microsoft in the next quarter.
Let's go.
What would he have to announce?
He would have to announce we solve quantum computing.
Yeah.
But I mean, to my earlier point, like a lot of really smart tech people that I talk to do say, yes, like this is the century where we will solve quantum computing.
Yeah.
It's going to take a long time, probably longer than we estimate. It's hard to exactly, forecast it out. But when we do, it will result in crazy, crazy new abilities.
Yeah.
One guy I was talking to, a very successful founder, was like, so million qubit, quantum computer by 2040, 2050, talking to somebody else. And it was like, yeah, maybe. And then he's like, so Dyson sphere by 2100. And it was like, yeah, that sounds about right. And it was like so casual, but I was like, that sounds crazy, but also like that things are really accelerating and we're building crazy stuff. Like, you think about 100 years before we can talk to the computer now. 100 years ago, we didn't have computers at all.
Yeah.
Nothing.
Yeah.
It was like, it was like trains are cool 100 years ago.
Yeah. Trains are still cool.
Trains are still cool, but
we don't need more of them.
We
don't need more of them, but
yeah.